Alright, in this scene we're looking at currency idempotency. This is how the system avoids applying the same request twice. The core idea is simple. Each request carries a request ID, or RID. And if the same RID shows up again for the same operation, the system can treat that second call as a replay instead of mutating the wallet again. So this is mainly about retry safety. If a client retries a request, you don't want to double credit and double debit or double transfer by accident. Before we run the scene, this panel is built around that RID flow. We can choose an operation, append the RID to the source ID, run it once, or run it twice with the exact same RID and compare the outcome. Alright, let's run it. Like the other demos, teach text is turned off here just to keep things clean for the video. And over on the right, we've got the currency basics panel again. This time, there isn't there to seed balances. It's there so we can watch the wallet updates live while we test replay behavior. At the top of the idempotency panel, we've got owner A, optional owner B, and the resolved currency service. Just below that, we've got reason, source, and RID. The important bit here is the RID. This gets appended to the source ID using a simple convention. We just add a pipe character, then RID followed by the token. So you end up with your original source with that request ID added on the end. The RID is what the idempotency layer matches on. And there's a new RID button so we can quickly generate a fresh request ID for a brand new operation. Below that, we choose the currency and the operation. Set, credit, debit, or transfer. And then we enter the amount. For this demo, I'll start with credit. You can already see the current balance on the right in the basics panel. So first, I'll run it once with the current RID. That first call is a normal mutation. The credit goes through and the wallet updates. You can see that reflected immediately in the basics panel on the right. Now I'll run the same operation again, using the exact same RID. If idempotency is part of the composed stack, this second call should not apply the mutation again. So the balance should stay exactly where it is. The run twice button just does the same thing automatically, sending the same request twice with the same RID. And that's the important part to watch on the right. The wallet should only move once. So if the balance increases once and then stays put, that's exactly what we want. If it increases twice, then your current stack probably doesn't include idempotency. That's also why this panel includes a small warning in the teach text. From the public API side, we can observe the behavior, but we can't directly prove composition just by looking at the service. So this scene teaches idempotency by outcome. Same RID, same request, no second wallet mutation. If I want to perform a genuinely new request, I just generate a new RID. Now the system sees it as a fresh request instead of a replay, and the mutation can happen again. So the mental model for idempotency is simple. Reason explains why the operation happened. Source identifies where it came from. An RID identifies this specific request instance. If the same RID comes in again, the system can safely treat it as a replay instead of doing the mutation twice. That's the whole point of this scene. Use the same RID to prove replay safety. Use a new RID to prove you're making a brand new request.